Hi, I'm Quốc 12 years old, secondary 1 from NS High School. Right now here, we're still continuing with our ordinary differential equations. Well, in this time of our ordinary differential equations, we are at the part for exact form. Well, in this part for our exact form, we're starting on an example. But in this exact form type, we're just going to revise first the first order exact form. So I'm just going to give a very simple first order exact form. I guess, for example, e to the power of 2x, then you times the first derivative of y, then you add 2 e to the power of 2x, then y, and you make it equal to x. This is just a very simple type of first order of this type of exact form ordinary differential equations. So first of all, in this, here you have dy dx. Then on the other side you have y. Then you take a look. What if you times dx on both sides? Well, so I'm just going to write it a little bit longer. Then after that, on this part, what you get. So we'll just combine these two together. D. Then here you have e to the power of 2x. Well, definitely that means it will be inside. That's how you get this extra 2 at the same time. Well, you still have this y. That's how this y is gone. Then after that, you integrate on both sides. So this side will be simple, just like this. Then on the other side, half x squared, then you add c. So y, it will be so this will be all for the y. So y is just simply dividing this to the other side. Well, since it's divided, so that means the power is an extra negative. So that's what you get here. Well, if you want to verify this, I'm just going to show only for this part, then afterwards, the second derivative I'm also going to verify. So to verify this, y you already have here, you only need the first derivative. So the first derivative, what you need, since you see these two are multiplied, that means we're going to use the product rule here. So when we use the product rule, the first part, constant, well, it will become 0. This front part, when differentiate 2, cancel out with the half, you get x. Then you directly times this. Well, for the other part behind, here, differentiate, you get extra 2, and this negative. So this is the part that you get. After you just have to sort them all inside again. And at this part, you'll see this part here, a negative of this whole chunk, and this part is a positive of the same thing. So that means you cancel out, then all that you get is x. So this first derivative example, I'm just going to add it here, just to say that it is right. So next part, I'm going to move on to the second derivative. So this second derivative example of the exact form that we're going to have here, you have x cubed. This x cubed, you times the second derivative of y, then you add 2x squared dy dx. So dy dx is the first derivative of y. After that, you have to subtract 2xy. And this part is equal to x. So first, let's check the discriminant, whether it satisfies the discriminant. So here we're taking it as a2, here's a1, here's a0. So from that discriminant, here we differentiate twice. So we take the second derivative of this part. So second derivative of x cubed, you get 6x. Then here you take first derivative. So first derivative you're going to get 4x. But wait, here, although from here it's a positive, but in that part you need to change it into a negative. Now here negative, okay, negative, well in the discriminant is a positive. Then here, you just take it. So that means in all you get 6x subtract 4x subtract 2x, and that'll give you a 0. So that means it's right, and we can use that part. So when using for that exact form part, first of all, D is on the very outside. So D is already on the very outside. Inside next will be a2, because that is the second derivative. So you have a2. That means it is the x cubed. Then after that, you add this part that you're going to add, a1, so 2x squared. Then you subtract a2, well, you differentiate it once. So that means it will be, you have to subtract 3x squared. Then after that is your y. Oh wait, there's still a d here, okay? And then this part that you're going to have is equal to x. So in this part, we're just going to change this into just a negative x squared. So you'll need to use the square bracket here. So this is a part that we're going to have for now. Well, in this part for now, d, that means you can integrate on both sides. So we integrate on both sides. This part, well, it's just that this d, it's gone. The rest here stays the same. Well, on the other side here, you get. So you integrate this part, it's a half x squared. Then you add your first arbitrary constant c. So that's what you get here. Then next, well, what do we think of when we have this part? We have this d, first derivative. So that means this now changed into a first derivative ordinary differential equation. We have first derivative, we have a function of x times y, and we have a function of x on the other side. Wait, what if we just change this into only the first derivative here? If we have only the first derivative here, that means we divide x cubed on both sides. So we divide x cubed on both sides. That means here you get a negative 1 over x. Yeah, here is a y. Or you can also choose to write it as x to the power of negative 1. Either way is possible. Then this will be equal to half x power of negative 1. So I'm just going to tell you these two ways of writing both can. After that you add c1 x to the power of negative 3, like this. What do you think of when you get this form? First derivative, function of x times y, another function of x. So of course, you will need to think of those methods that you have learned before here. That we have learned before. Well, the most familiar case here right now is the integrating factor. That means, first of all, we have to find the IF. Taking the IF, it is e to the power of. So we're going to use negative, because here is that negative. Then we have 1 over x, then dx. So 1 over x and dx is asking what differentiates to 1 over x. Well, definitely it is ln x. But ln x, ln, it is logarithm. It is in the logarithm part. E, it is in the exponential part. So what do you think of these two when they're together? Well, that means you can just cancel them out, as they're the inverse operations of each other. And the last one we'll get is inverse x, or you can also write it as 1 over x. So then this part we have the times on both sides of the equation. And that's what we're going to get here. Well, just take note that this dy over here is actually dy dx. So since that this is dy dx, we can just times that dx on both sides. Then from this part, this front part here, you can just put them into d. Or here we have x power of negative 1. Okay, after you have this y. So that when it differentiates with respect to y, you get this part, and when it differentiates with respect to x, you get this part behind. Then after that, this will still be the same. Then you differentiate on both. This is integrate on both sides. So from this part you integrate on both sides. Next part you will get. This is x to the power of negative 1, then you times the y. So this part is just the same. Well, on the other side. On this side, well, you can choose to think of them as separated. So that means this front part will be of x to the power of negative 1. But you also have this extra negative in front, like this. Then from this part behind, you also get a negative. C1, you get C1 over 4. Is it? Is it C1 over 4? It is C1 over 3. Like this. So this is the part that we have. But wait, this is indefinite integration. What did we miss out? Well, first, we missed out the actual constant behind. So this is actual arbitrary constant. But at the same time, we can also choose to change this part, which is constant over constant, into, well, we can just change it to another constant. So you just get a form like this. Then you want to find y. So you're finding y. That means you times x on both sides. Since this is x to the power negative 1, you need to times x to get rid of that. When you times the x here, first part, it is also x to the power negative 1. So that means the x will just be gone. Then you subtract. Here is that arbitrary constant. Then here it is x to the power of negative 2. Then you add c2 x. So this is y that you will get. But are we sure that this is right? Are we sure that it is wrong? Well, we're not sure about that. So we'll need to verify this. So we verify this part. We already have y. We need first derivative of y, we also need second derivative of y. So I think I'll just move this verified part down here. First derivative will be, okay, constant. When you differentiate, it's just 0. So this first part we can ignore already. The second part here, negative and a negative becomes positive. So we get 2c3, then x to the power of negative 3. Then behind here, x becomes a 1. But beware, this part, although it is another constant times a constant, we don't change it. Because at last, we're going to put them all together. And if you keep on changing it, you have a C3, you have a C4, you have whatever. And this front part, we can choose to change it because, well, we're not using it ever again. For this part, we need to use that. Then after that, you get your second derivative. So your second derivative is negative 6c3 x to the power of negative 4. Then this part is another constant. So constant, well, we just ignore that again. So at last, we put all these three parts into here. And we have to check whether it is equal to x. So, firstly, second derivative, you only need times x cubed. So, you get this, a negative 6c3x to the power of negative 1. Then, your first derivative, you have to times 2x squared. So 2c3 the x squared, from here you get x to the power of negative 1. 2x squared. But wait a second, here you already have a 2, then here you need times another 2. So that means you get 4. Then y, well y, you have to be aware of this part already. Negative and a negative, so it's still positive, half and a 2 gives you a 1. Then x, power of negative 1, and x, wait no, it is this part. So here is x, and this constant here, that means you'll get an x. Then after that, negative, again it's positive, 2c3, then x to the power of negative 1. Then after here, subtract already. Subtract 2c2, x squared. Okay, let's see what we will get. X to the power negative 1, negative 6 and 4 add 2, well that gives you a 0. Then these two parts will give you another 0. So what's left is this x. So what you get at last from this verification part is an x. So you got this x and you compare with the starting, you also have that x. That means it is right. So this y here is right. Well, let me just tell you from here, you see those constants there. So it's actually telling you that it is a general solution here. Okay, so for this time, I hope that you are clear so far, and I'm just going to end this lesson here. So if you like our videos, don't forget to subscribe to our channel. And we'll see you in the next lesson. For this ordinary differential equations, this part is the exact form. Okay. Thank you for your watching.